Good morning.
Good morning.
That was really well timed to me. If I tried harder, it wouldn't have worked. All right, so welcome back on this wonderful Monday. We're going to kick it off with a quick, short two-proof lecture segment, and then done, back to work mode. Double check the board, see what it is that needs to get checked off today, and then I'll let you know how we did on Tuesday. It felt like Friday. Tuesday, last week Tuesday. All right, so normal writing utensils, you might want a straight edge because we're going to be drawing a couple of triangles, only two little diagrams. Here we go. Let's kick it off. Let's start off with a given statement. Given line segment AB is parallel to line segment B. Wait. I'm looking at the wrong one. I'm looking at the wrong one. Get rid of just this part. Just this part. I'm sorry.
Oh.
If you're writing in pen, just scribble it out and then write underneath it. If you're in pencil, eraser. Sorry, I was looking at the wrong one. Okay. Given triangle LMN is an isosceles triangle, and I want to leave just enough room right here to draw my figure. This isosceles triangle has a vertex M. Woo! Good morning.
Teachers, at this time, please release all the STAR testers to the cafeteria. Thank you.
Thank you. If that's you, go, and I'll see you on my YouTube channel.
Hey, you want to take your book?
That's not mine, it's Armando's.
Okay. Thank you. Good luck. And line segment MP is an altitude of triangle LMN. So these are the two things that we are given. These two things right here. We are being asked to prove triangle LMP is congruent to triangle NMP. All right, lots of scribbly writing. Let's try to decipher what this means and draw a picture. I'm going to start with the first given sentence. It says triangle LMN is isosceles. Okay, so I'm going to draw something that kind of looks like an isosceles triangle. I'm going to put the base down here. I'm going to put the sides up here. And that kind of sort of looks like, okay, it's leaning a little bit, but it kind of looks like an isosceles triangle. Remember, all of our drawings are drawn by Notoscali, right? Notoscali? Yeah, okay. So we're good. Vertex is M. So I'm going to name this one up here M because it's the one that looks like it's got the two congruent-ish legs. And then I'll just name the others M and N. So now I have triangle L, M, N, and here's my vertex M. Line segment MP is an altitude. Go back to your notes from Monday, Tuesday last week. And remind me what altitude was. I need to go back to my notes from Monday or Tuesday last week. Here we go. Oh wait, that's the 17th, the 18th, 19th, 20th. Oh no! Where? I gotta find my notes too. There's 4-1, there's 4-2. Here's 4-3. The start of 4-3. Hopefully by now you guys have gotten at least to 4.2 in the video notes. Hopefully, yes, maybe so.
Yes.
Okay, good. I've got Tuesdays. Okay, so we're looking for Mondays, where it has the definition of all of the all of the things. Find altitude for me in Mondays. It would be Monday's notes, which I don't have. Sad moment of my life. I hope someone didn't borrow my Monday's notes and wander off with them because now I don't have them. And I'm gonna cry. I was not naming names.
Altitude.
Altitude.
Segment whose endpoints are a vertex and a point.
I can't hear. Vertex and a point where?
And a point of the line
A
containing
point.
the opposite sides that the segment is perpendicular to the line.
Oh, okay, so we look at the side opposite that vertex, and we pick some point on here, so that way when we draw the line connecting this point and this vertex, we end up with a right angle. Okay, it doesn't look it, but again, drawn by not to scale. Doesn't have to look it, we marked it, and so it is. Awesome. And that's all we have in order to prove that this triangle, LMP, is congruent to NMP. All right.
Wait. Oh.
Yeah. Now, do you want to do this kind of as a flow charty thing?
Well, I mean,
Or do you want to do this as kind of this very linear, the two-column proof that we're comfortable with?
basic logic obviously is going to be congruent.
Okay, so tell me how.
Because
With your, no, tell me how with your basic logic.
I know I'm wrong. 'Cause, like, it's, there can be different things that make it. Well,
Well-
like, does it have to connect to M?
Up to here?
Yeah.
We definitely have to use that M. This is the figure that we're being told.
Never mind. I like it.
You don't like what you were thinking?
Yeah.
Okay.
I disagree with what else.
You disagree with what you were thinking. Well, give me the start of what you were thinking. See if we
It's
can't.
like, if
How do we show these two current triangles are congruent?
the altitude was splitting it in half and it created right angles and
But how do we know that this is directly in half?
that's what I thought.
But how do you know that?
That's where
Like, I love where you're going with it because it hits at this right angle. It's got to cut this thing in half. Okay, let's go with the definition of what we know about isosceles triangles first of all. We know that isosceles triangles have two legs that are congruent to each other. Which ones?
Oh! The ones at which the vertex is on.
The ones that create the vertex. Fantastic. So let's mark those.
Yeah.
We know that these two are going to be congruent because of the definition of what it means to be an isosceles triangle. All right, so we're going to do this kind of flow chart thing here, okay? And then we'll turn it into our two column. So I'm using a pencil right now, my Star Scholarship Fund pencil. Woo! All right, so we know that these two are congruent, and I'm going to put a note here. This is my definition of isosceles. This is going to be the start of our flow chart so that we can organize them into our two column. Gentlemen, thank you. All right, so now we know these two are congruent to each other. We know that this segment is going to totally be congruent to itself because it's the same segment, right? Yeah, so that's called the reflexive property. So I'm going to jot it down in here. The reflex property. Okay.
Reflex property?
Yeah, I'm abbreviating it. Abbreviating it? That's a word? Abbreviating it. It's the reflexive property. It's a reflexive property. Okay, so we've almost got it. Now in video notes 4.2, one of the first things that we saw to prove that triangles were congruent was this side postulate. That if we could show that three sides of any two triangles are congruent, then we know that the whole triangles are congruent to each other. So we have two of the sides, so all that's left to do is show that these three are congruent Once we can do that, we're good. So the question is, how do we show those two sides are congruent?
What is it?
How do we know it splits it in half?
There's-
I mean, I
there's-
like that, but
there's
what
the
says it?
altitude,
Because it's a bisector? Double check the definition of altitude again, and just double check that it becomes a bisector. Because if it does, you've got it. And I don't have my notes from Monday, they've walked away, so I'm relying on you guys.
It's perpendicular.
It's perpendicular, yes, which means it hits at a 90-degree angle.
Yes.
But that's all it says?
Yeah.
Yeah. So if we could find a way to show that it's the bisector, we got it. But and this is the hard part, is finding that reason. Okay, keep looking, keep digging. Flip through any part of your notes, your video notes, anything that you've done. And if you're just sitting there going, oh God, you probably should get your notes out and be flipping through it. ¿Notas? ¿Dónde está? Ahí. Help me out. Look, I've got the key over here, and it's talking about the bisector, okay? So you're on the right track, but the question is how does it say it's a bisector? That's what we're stuck with, because we need the reason. Why is it a bisector?
Well,
Because all the
well, if you think about it,
Equidistant.
Is that what the altitude says? Because the altitude is equidistant to
it's the other side.
the other side. There it is. There it is. Okay, so that was part of the definition of altitude, yeah? So we're going to get rid of the question marks, and we're going to put definition of altitude. That was stellar. I seriously, I had no idea how to get them congruent. Fantastic. Let's organize this into our proof, because we did it, yes? We showed that all three legs of this triangle are congruent to the three legs of this triangle. And by that side postulate, we can say that the triangles are congruent because we've got all three sides being congruent. So now we just got to write this as a 2-column. Yes, sir.
What does it say to the right of the triangle?
Here?
Yeah.
Definition of isosceles.
Oh, okay.
Yeah. And we're about ready to write it all out. So let's start our 2-column proof.
altitude, yes.
We need our statements and our reasons. I'm going to make my statements shorter than my reasons. More narrow. Okay. Statement number 1. Always start with your given. Let's scoot this up a little bit. All right, always start with our given. What was given?
The element is isosceles.
Triangle element. Yeah. MOP. Important that you say the name of that little symbol there. Triangle LMNOPQRS TUV. No.
Okay, you're getting really confused with these letters.
I was starting to sing the alphabet song.
I know, it was
Like,
how
what?
many sides is this stupid?
Sorry, I'm sorry. It is 3 sides. Stop at 3 letters. With vertex M. I hear some music in this general vicinity.
Is Adrian?
He's a little loud.
It's probably there.
Does he?
Yeah, it's probably there.
Is Adrian?
Thank you. Just somewhere here.
Adrian.
This here's the one that's hearing it. All right, what else were given? Line segment MP is an altitude. I'm going to have to abbreviate altitude because I'm out of space, but you don't. Of triangle LMN. You don't abbreviate, you have plenty of room. I have to abbreviate because I am lame and didn't give myself enough space. All of those were given. All right, number 2. What was the second thing that we had said?
Definition of isosceles unit.
Yeah. Yeah, we use the definition of isosceles triangle to give us that line segments LM was congruent to line segments NM. Something like that. All right. Step number 3. What's the next thing we can say?
Slice of property.
Yeah, we did this one, right? Okay, so the reflexive property, reflexive property gave us that line segment MP was congruent to itself. And I know that seems kind of awkward to say. Hey, why do you say that it's congruent to itself? Obviously, like, duh. But we have to imagine that this 2-column proof writing thing is writing it as if we were trying to tell a computer how to do it. And computers, honestly, are really, really, really dumb. Hey.
Smart computer.
They're not, I mean, even smartphones are kind of dumb because they only do exactly what you tell them to, right? Even though it looks like they're doing something, like they have a mind of their own, no, they're really just doing whatever it was that you told it to do, even if you forgot what that was because you did it like 5 seconds ago. It remembers and it does it. So if you forget a step, it's going to look at you confused, like, I don't get it. Okay? All right, we're almost done. What's the next one?
Definition of altitude.
Yeah, we use this definition of altitude thing. Altitude. I didn't spell attitude, did I? Altitude. Definition of altitude, and we use that to tell us that LP was congruent to NP, and we have 1, 2, 3 sides, so the side, side, side postulate gave us that the triangles that we were looking for are congruent. Oh God, I'm going to run out of room. I'm going to rewrite this part. The triangles are congruent just because I ran out of room. And I want it to look pretty. Triangles LMP congruent to triangle NMP. We got to where we wanted to go, so we're done.
Yeah, we're going to do that for all the postulates or just this one?
I don't think we're gonna have time to be able to show it for all of them, but depending on the name, it tells you what it is that you're gonna need to find. So I have another example sitting here that should give us one of the other congruences that we're working with. And I'm gonna try to make it that side angle side 1, basically. Sass! All right, seems pretty good, fairly simple. We're doing okay? Give me a quick read. Thumbs up. This made sense, though it's still a little weird because you don't think like this very often. So give me a thumbs up. It's okay, even though it's still a little weird. Give me a thumb sideways if you're like, this is so beyond weird. And give me a thumbs down if you're going cross-eyed and it's making no sense. Vote now, real quick. Thumbs up, it's okay, even though it's a little weird. Thumbs sideways, it's completely weird. Thumbs down, you're going cross-eyed. Cool, thank you. Mostly thumbs up. It's feeling okay, even though it's kind of weird. Awesome. Awesome. All right, we're going to try to do one more. We're going to try to do one more. We've got very limited amount of time left. But I want to be able to, so that you have some time at the end of class to work on things. All right. Here we go. I'm going to hope this gives me the one I want. All right, so we're going to be given that B is the midpoint of line segment AE and line segment CD. And with that, they want us to prove that triangle ABD is congruent to triangle EBC. And so we've got to draw our figure, and the figure that I have looks something like this. And I need to label A, E, C, D, and B is this point here in the middle. And that's all I'm given.
Wait, what is that? A, B, and U?
ABD. Sorry, I will clean that up. Thank you. Make it look a little prettier because it looks all ugly.
It looks like a tie.
It kind of does look like a bow tie. All right. So statements and reasons, going straight to the 2-column proof. And I'm going to write really tiny because I didn't give myself very much space. All right, so number 1, I'm going to write my numbers out here and we'll go for the whole line. B is the midpoint of these 2 lines, which means what do we know? Automatically. That they cross at B. What do we know about the pieces of line on either side of B? They're the same size. Why do we know that these are the same size as each other? How did I know that these were congruent? What told me?
The B.
The B. The fact that B is a what?
Midpoint.
Midpoint. So I got these 2. Remember, we're going to do our quick notes. I got this because it was my definition of midpoint, yes?
Yeah.
And I'm just doing a really quick note to myself so that when I'm ready to write down my 2-column, I have my notes. All right, what else do I need to show that this is congruent? Well, if I tried it side, 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 I'd need to somehow show that these sides are congruent. And I don't have any way to relate those sides. Right? I mean, I don't have anything parallel. I don't have any measurements. These aren't touching in any way, shape, or form, so I can't say that there was a midpoint somewhere. Right? So I can't get these 2 sides. But I have another congruence theorem that was called side angle side.
Sides.
Size. If I could show that these 2 angles were congruent, then I would have it by side angle side. How do I know those 2 angles are congruent? What could I use to say they're congruent? Huh? What's their configuration? What kind of shape are they making?
Oh, if they're doing what?
Oh,
Right here.
triangle.
Right? We're looking just at those, narrow your focus, look at just those angles. Yeah, it makes like an X, right? And when we made an X with 2 lines, those angles that were on either side of that middle point,
RQ.
none always, but they were congruent. Why? What were they called? Going back to the notes. What was our,
Angle.
huh?
Opposite angles.
Opposite angles?
No?
No, the name is a little more specific than that. Because I see what you're getting at. They're like on opposite sides of that vertex thing.
Reflected.
But they have a specific name that gives it this property that they're always congruent. And it's a little bit more specific than just opposite. So we need a little more detail. This is another one of those recall moments. What was our symbol for recall in this class?
Question mark?
The recycle, because we're recycling information. Awesome, so this is another recycle moment. We're recycling our information.
Oh, perfect.
Okay, what was the name of that one? I will give it to you, and then you will recycle and go back to your notes to find it. They are called, and as soon as you realize what it is, please give me no yeah.
Vertex.
They're vertical
Oh, yeah.
angles. Because vertical angles are always congruent. And now we have the information we need. All right,
Oh, yeah.
turn it into your 2-column proof. Start with your given. So always start with the statement that's given. Always
Oh.
end with the statement that says proof.
B is the midpoint of A, E, C, D.
Do it, write it.
Ah.
And you need to somehow make it fit the space you have left. I'll race you.
I'm done.
You're done? Show me.
Oh, yeah.
In a minute, right?
Forgot your reason, man. It's good.
You're right, thank you.
Happy Thanksgiving, everybody.
Happy Thanksgiving.
No, por happy, se murió Chespirito. It ain't happy.
I'm leaving stuff blank. Look at me, I'm such a rebel. I'm leaving stuff blank for you guys.
You're so cool, man.
I'm so cool.
You're like the fashion section. Nope. Casey had the food.
All right, I gave you one angle. You have to give me the name of the other. And I will give you the name of the theorem. I'm leaving all sorts of stuff blank here for you guys.
Perfect.
Oh!
That's what I needed.
This one's going to have two little congruent statements in here.
Kind of throws me off.
Right? We use the definition of midpoint to give us this congruent to this and this one congruent to this
Correct.
one. So make sure you have two congruent statements in here on the statement for number 2.
Yoki dokie.
The reason I'm leaving some of these things blank for you guys is coming up in a skills check. I may drop something like this and say, finish the proof. And it's going to have a bunch of blank spots. You guys have to fill it in. All right? So we're just getting you ready for that. All right, good job, everyone. Thank you.